Hello everyone, I'm Liyulingyue, a paddle and Ernie developer expert. This is a Raspberry Pi 5. It's made up of 3 parts: a screen, the main board, and a camera on the back. Today, starting with this Raspberry Pi 5, I'm going to show you how to build a click, shoot, and translate device. We'll be using Llama.cpp and the Ernie large model. To begin with, we'll SSH into the Raspberry Pi and install the necessary dependencies. First, we'll install Llama.cpp. This will be used to run the Ernie 0.3B model. Step 1. Create a virtual environment, and then activate it. Step 2. Install Llama.cpp and other related packages. You can use the I flag to select the fastest pip mirror for you. After installing Llama.cpp, we need to download the model weights. There are 2 ways to download the model weights. First, you can download it from Hugging Face. After installing the Hugging Face CLI tool, you can use the command line to download the Ernie 0.3B model, which is already in GGUF format on Hugging Face. The second method for downloading the model is through Model Scope. You'll need to install the Model Scope library. Once installed, you can use the command line to download the corresponding model file from Model Scope. Next, let's start the OpenAI compatible server using Llama.cpp. We'll use the model argument to specify the model file we just downloaded. The default server port for Llama.cpp is 8000. Now, let's open a new terminal to call this service. First, activate the virtual environment. Then, install the OpenAI library. After the installation is complete, enter the Python environment. Import OpenAI. Set the server address to port 8000. Send the question, "Hi, how are you?" to the model, and check the model's response. As you can see, our deployed model has given us a proper response. Now that Llama.cpp is set up, let's start deploying our local OCR project. For this project, our OCR recognition will rely on RapidOCR. First, install RapidOCR and ONX runtime. Once they're installed, it's ready to use. Here, we've already uploaded an image named input.png locally. Next, let's edit the file. With just a few lines of code, we can run the RapidOCR inference. It's important to note that our local image is named input.png. Make sure this matches the name in the code. Run the script, and you'll see the inference result. Next, let's wrap RapidOCR into a service for easier access later. Our service will be provided via FastAPI and deployed on port 8001. Let's start the service. Looks like we're missing a package. Let's just install it. After it's installed, let's start the service again. And you can see it started successfully this time. Finally, let's configure the camera and the PyQt5 interface. First, install the dedicated camera library for the Raspberry Pi 5, which is used to read images from the CSI camera. Next, let's take a picture using PyCamera. First, import the PyCamera library. Start the camera. Take a picture. Save the image. As you can see, the captured image has been saved locally. Lastly, let's install PyQt5. We'll create a file to display the user interface with PyQt. In this file, we use PyQt5 to display the window. The screen will refresh periodically. It calls the services we've already deployed. When the button is clicked, it first performs OCR, then translates the text using Ernie and displays the result. Since PyQt5 is for displaying a graphical interface, this script must be run on the desktop, not in an SSH session. So let's go back to the desktop to run it. Let's open a terminal and run the file we just created. Finally, let's see the result, 10. And there you have it. Our hardware project based on Ernie 0.3B is now complete. I hope this inspires you to develop more interesting large model applications using edge computing.